Good day, ladies and gentlemen, and thank you for the introduction, Mr. Wei Xiang. It's good to see so many familiar faces here today. It's actually so many familiar faces that I hope that everybody will be able to get a bit of lunch in today. Given the attention it's getting in Singapore, it seems to be a quite hot topic. At the same time, I'd like to thank the MPA and Mr. Wei Xiang for giving us the podium here today. It's great and it's a pleasure to speak to you a bit about ammonia. Because as in my agenda, and as it will have been in many of your agendas, ammonia has been one of the main topics that we've been discussing about. I indeed represent Vopak Terminal Singapore. And Vopak Terminal Singapore is a joint venture between PSA and Royal Vopak. Now, from my height and the mismatch with the height of the microphones, you might have already been sort of aware that I come from the Dutch side of the... It's okay. From the Dutch side of the joint venture. Vopak has been in Singapore for many decades, and at this point in time, this year, I'm very pleased to say that we will celebrate our 40th year anniversary at Pulau Sebarok, just off the coast of Sentosa. Pulau Sebarok is also the location from where we supply about 15% of bunker fuels in Singapore. In the second half of this year, we plan to do the scale-up for biofuels into the Singapore port at Pulau Sebarok. Over the past couple of years, we've been doing almost all the pilots for biofuels from Penjuru terminal, which is located on mainland to us. Of course, we'll talk about ammonia in a little while, but I'd also like to say that at the other terminals in Singapore, Sakra, Banyan, we handle almost all the methanol that goes into Singapore today. Today already, we handle indeed ammonia at Vopak Banyan. It's a 10,000 cubic meter tank capable of handling 80,000 tons of throughput on an annual basis. I think, give or take a few thousand tons. Normally we do between 60 and 65,000 tons at Banyan. I actually joined Vopak back in 2007 as a management trainee, a management associate at that point in time. What we tend to do with our management associates is that for training purposes, we first send them at least a couple months to our sites. I worked on a site called Vopak TTR. Would be surprised if anybody would be aware of it, but it's a site in the port of Rotterdam where we actually handle the most dangerous chemicals in the world. We handle products like aniline, of which a few drops on your skin will impair the ability of your blood to take up oxygen. We handle products like phenol, which can cause severe burns, but also products like acrylonitrile, which are produced from ammonia and in the end used for Kevlar in the industry. During those days, I was taught to get a quick feel for the hazards and the risks of the products by, of course, looking at the NFPA standards. There's a lot more granularity to it, but comparing products with each other, it typically helps if you put them on the matrix, usually the consultant matrix on the left. What you'll quickly see is that ammonia is a hazardous product. It's very toxic, many of you will be aware, but it's not as flammable as many of the other products that we already deal with today. It's stored at roughly minus 33 degrees Celsius because of the fact that it's a gaseous product at ambient temperatures. There's a lot more to do, but I would definitely say read up on the MSDSs, and that'll give you a lot more detail on ammonia. As Vopak, we already handle ammonia in quite a few locations. Vopak itself has a history of developing its own standards. I think the shipping industry had a good wake-up after the Exxon Valdez event in 1989. The main event which changed the course of the tank storage industry was the Buncefield incident in 2005 in the UK. Quickly after that, we started to develop our own standards, which, for example, includes the mandatory implementation of independent overfill protections combined with UPSs on every individual terminal that we operate as Vopak. When it specifically then comes to the handling of ammonia, we also started to develop our own standards at that point in time. We could see that the seaborne trade of ammonia was anticipated to grow quite a bit, so we thought it would be way better to start developing our own standards. If one were to do detailed research, like many of you will have done in the past couple of months at least, and probably in the past couple of years, the landscape of ammonia regulations, ammonia standards, ammonia guidelines is quite distributed. It's not as well embedded into legislation in many countries as it is with some of the already existing products that we've got. So we took the API 625, which is the typical building code for refrigerated storage. We took the liquefied gas handling principles, and we took the best practices of all the gas handling terminals that we've got in our network to develop our own standards, like we are using here today at Vopak Banyan. Ammonia today has a total market of about 200 million tons. Production capacity is quite a bit higher, but especially given the fact that there's a lot of pressure from the higher LNG prices, the actual production and uptake over the past year will have been lower. It's probably about 180 to 190 million tons. It is relevant to know, though, that if you put that in a bit of context, the total methanol production is only half of that. So it is a product of which the handling capabilities are out there in the market. At the same point in time, only 20 and a bit million tons of that ammonia is being transported overseas. The far majority of it is produced and consumed domestically. So it's only just over 20 million tons that actually is sent out from locations and transported over the world. The Vopak terminals that I showed you on the previous location handle just short of 2 million tons, about 10% of that volume. Over the past couple of years, many of us will probably have had at least a few moments of surprise or confusion when looking at the rainbow of colors that has emerged for the different green solutions that we've got in the world. Ammonia production today is very far, at the very far end of the gray scale of production. There's different figures out there, but the total production of ammonia at this point in time creates about 1.2% of global CO2 production. I think if you compare that to the air industry, or if you compare that to the maritime industry, they're both roughly about 2% of total production of CO2. Producing 1 ton or using 1 ton of ammonia will generate 2.7 tons of CO2 at this point in time. The scale-up of ammonia and the scale-up of ammonia supply chains will definitely be a substantial challenge for us going forward. If you take the previous volumes that I mentioned and you put them a bit in perspective, I think it's good to be aware of what the magnitude of that challenge is. If by 2050 Singapore uses or aims to get to net zero by using 50% ammonia-based fuels for its energy production, the total amount of ammonia required is roughly similar to the total amount of ammonia currently being transported overseas. If 5%, which is now the forecast of some by 2035 or 2040, if 5% of the shipping fuel comes from ammonia, we're already looking at volumes of around 10 million tons of ammonia, which has to be bunkered here in Singapore on an annual basis. So those are huge volumes, and that'll definitely need quite a bit of attention of all of us to move ahead. There's challenges on all ends of the supply chain. It's on the cracking, power gen, bunker side. It's on the production side of it through electrolyzer technologies. But the scale-up will also be a challenge for the existing industries. If you look at the magnitude and the sizes of transportation of ammonia, it's going to be very close to the volumes that are being transported for LNG. If one were to think of the size of a typical LNG tank at this point in time, you'd be looking at somewhere between 160 to 220,000 cubic meters. When taking into factors like stress corrosion and the limitations that is posing on the asset integrity of tank sizes, today you'd only be able to build about 85,000 cubic meters in maximum tank size. The main limitation there comes from stress corrosion. Stress corrosion is the combination of ammonia and oxygen content having a negative effect in combination with the low temperatures on the steel alloys that are being used to construct tanks. If you were then to combine that with the dimensions as per API 625, you get to only that maximum amount, maximum size of 85,000 cubic meters. There are ways to handle that and to deal with that. Yeah? Already in today's setup of tankages, people would typically not use, I also not advise anyone to use, manganese carbon steel, or nickel steel. You'd always go for low yield strength steel type proportions. And if you combine that with very extensive stress corrosion mechanisms that you put, or stress corrosion prevention policies that you put in place to make sure that the oxygen content and the water content is being carefully managed, there is a very good way to make sure that it doesn't happen. I think today already quite a few words were spent on cooperation and working together in supply chains. The challenge, however, always is, what does that look like, right? So what would one then do in practice? So therefore, I thought it would be helpful to share at least one example from you of how we've tried to move the ammonia supply chain at other locations. Already in 2020 and in 2021, there were discussions taking place in Rotterdam on the developments of ammonia supply chains. At that point in time, people were still contemplating whether or not to transport ammonia on inland barges, pressurized or refrigerated. As such, we undertook an in-house QRA assessment to assess the differences between the two and the impact that it would have on the QRAs of different sites. So this is typically where the interface between industries has to be managed, and it requires input from both sides. With that, we've also probably come to a point where it's good to hand over to the specialist who will talk a bit more about bunker. But I'd also like to say, probably as a bit of a conclusion, that for many of the ammonia-related industries, we're not at the beginning of the development of ammonia capabilities. I'm also quite sure that we're not at the end of the development. So the next couple of decades are going to be quite interesting for us to see how it will move ahead. There's a huge amount of opportunities, but also a huge amount of challenges to overcome. And we as VOPAC look forward to working with you all after you've had your lunches.